So imagine I have a one-to-one function with inverse f inverse. If I'm given three pieces of information, f of 1 is equal to 2, f of 2 is equal to 6, and f of 3 is equal to 7, what's the inverse of 6? So what do I know? Well, I can see a 6 here as an output. So it strikes me the following is true. If I was to apply f inverse to f2, that's exactly what I'm interested in, right? That's f of 6. Okay, so what is this equal to? Well, by definition, really, of the inverse, really the cancellation, what do I know? This has to be equal to, so maybe I should rearrange this. So f of 6 is equal to this. This is equal to f inverse composed with f, of course, by definition, of 2, but that's just equal to 2. Right, it's the cancellation property. So f of 6, or f inverse of 6, sorry, is equal to 2. What about f inverse of 2? Well, f inverse of 2, same story basically. F inverse of 2, I can use this, can't I? So this would be f inverse of f of 1, same story, f inverse of f of 1, and of course that's equal to 1. So f inverse of 2 is equal to 1. Here's an interesting question. If I asked for f inverse of, so what about f inverse, let's say, of 5? Could I work that out? Well, no, because none of the outputs are 5 here. In fact, maybe a better one to put, just to really confuse us maybe, 3. That's a better example. So sure, I'm getting one input to f is 3, but in order to get f inverse, I need the output to be 3. And it's no good, right? I'm only able to get f inverse in 3 cases, actually, 7, 6, and 2. So not very many. So we can't work out this. Not enough information to calculate.